All right, so today we're looking at something that you usually find buried away in a tech closet.
Mm-hmm. Out of sight, out of mind.
Exactly. We've got the spec sheets here for the Kramer UHD-IN2-F16 and the UHD-OUT2-F16. And they just look like circuit boards.
Yeah, they're not flashy, but the whole idea behind them is what's interesting. Why slot a card into a big chassis instead of just buying a new standalone switcher?
Well, that's what I was thinking.
It really boils down to the difference between buying a disposable gadget and building real infrastructure.
Okay.
These cards are the inputs and outputs for the VS1616D matrix switcher.
So the switcher is like the mainframe, the spine.
The spine, exactly. And these cards are the nervous system you plug into it. If you need, say, better video resolution down the line, you don't replace the entire spine, you just swap out a card.
Okay, and I guess that's the mission for this deep dive then, to see if these specific cards, this nervous system, can actually handle the heavy lifting for a modern setup. Looking at the specs, the big headline is 4K support. But I see a little asterisk here. It says it's 4K at 60 Hz, but with 4.2.0 chroma subsampling. For you, the listener, who just wants a clear picture, does that 4.2.0 actually matter?
It does. It really, really depends on what you're watching, though.
Okay.
Chroma subsampling is basically a form of color compression. I mean, to keep the data flowing fast enough for 60 frames a second, the card has to throw away some color information.
The kind your eye won't miss.
Usually, yeah. In moving video, like a movie, you will not notice it. But if you're trying to project, say, an Excel spreadsheet with tiny red text on a black background, you might see some fuzziness around the edges.
So it's a trade-off. You're giving up a little color data to keep the speed up.
Exactly. You're working with a total bandwidth of about 8.91 gigabits per second. That's your highway speed limit. To get all that 4K traffic moving at 60 miles an hour, you've got to pack the cars a bit tighter.
I see. And speaking of traffic, what about audio? I usually just assume video cards sort of pass the sound along as an afterthought, but this list is pretty long. We've got Dolby True HD, DTS HD.
Yeah, 7.1 PCM. But for the people actually installing these things, it's the audio return channel, or ARC. That's the real standout here.
Oh, right. That's the feature that lets audio go backward from the TV back to the receiver, correct?
That's the one. In a really complex installation that saves you from having to run a whole separate audio cable all the way back from the display, it just, it simplifies everything.
Okay, so we've got the signal. But in the real world, you're not plugging these things into a TV 3 inches away. You're running cables through walls, ceilings.
Maybe across a whole warehouse floor.
Right. And the specs mention Kramer equalization and reclocking technology. Now, I have to ask, is reclocking just a fancy marketing term for a signal booster?
Hey, no, and there's a really important difference. If you just boost a signal, you also boost all the noise and jitter it picked up along the way.
Oh.
Reclocking literally rebuilds the digital signal's timing. It strips away the noise and it reconstructs a perfect, clean, square wave before sending it out again.
Which would explain how they get these distance numbers. The sheet says you can push full 4K up to 10 meters, so about 32 feet.
And if you drop the resolution down to 1080p, you can stretch that out to 15 meters. That extra 5 meters can be the difference between reaching a projector or, having to install another expensive repeater.
Okay, there's one more acronym soup I think we have to get through. The handshake nightmare.
Uh-huh.
Anyone who's set up a conference room knows it. The laptop plugs in, the screen flickers, and then nothing.
That's almost always an ED'd failure.
Right. So what are these cards doing about that?
They use something called ED'd capture. So instead of your laptop having to guess what the display is, the card just copies the display's ID data and stores it right there.
So it's always ready.
Yep. You plug in your laptop and the card immediately tells it, "Hi, I'm a 4K screen, send me this signal," without waiting to check with the actual monitor at the other end of the building. It forces a successful handshake every time.
I do notice these are listed as HDCP 1.4 compliant. That's a pretty standard content protection, but it is an older version. Some streaming services use the newer 2.2.
That's a fair point. For corporate use, live events, broadcast, 1.4 is perfectly fine. But it is a good reminder that even modular tech has generations.
I guess that's the whole point, right?
It is. If you eventually need that newer standard, you're not throwing out a multi-$1,000 switcher, you just wait for the next card iteration.
And that just circles right back to the physical engineering. All of this tech, the reclocking, the ED'd capture, the 4K processing, is all crammed onto a board about the size of a paperback book.
19 by 13 centimeters. It's incredibly dense.
It really changes how you look at that equipment rack. It's not just a black box anymore. It's more like a skeleton that's just waiting for new organs.
And that's the big takeaway from you. We're so used to technology being disposable, but in high-end AV, the goal is sustainability. It's sustainability through modularity.
So you can upgrade without ripping everything out.
Exactly, which leaves you with something to think about, doesn't it? Next time you're tempted to replace a gadget just because one feature is outdated,
Right.
could we, and really should we, be demanding this kind of modularity in our everyday consumer gear? Thanks for tuning in to this deep dive.